And number 37, in a 250 milliliter beaker, we introduce 40 ml of 20 millimole of CH3COH. Okay, 40 ml, 20 millimole. So the number of mole is basically 8. 20 ml at 10. This cannot be millimole per liter. Pay attention. I think this is... Okay, let's leave it millimole per liter. Let's leave it millimole per liter. This is 30 ml of NaOH at 20 millimole per liter and 110 milliliters of H2O. Basically, we have a combination of CH3COH, HCl, and NaOH. Now, you have to do the long version. The long version is أول شيء react HCl with NaOH according to the table. Okay. تاني شيء, the second one, whatever remains from the first reaction, react it with CH3COH. Okay. That's the long version. The short version, I'm gonna do it now, is basically just put all the species and start calculating everything in your hand. Okay, so I have HCl, which is H3O plus, added to HO minus, which is HO minus, added, this is not how you write a reaction, this is just something that I can solve it in my head, okay, to CH3COOH added with H2O, doesn't matter. I know that HO minus and H3O plus will react first. وحسب شو بيبقى منكفي مع CH3COH. The strong will always react first with the strong or the stronger. So, for H3O plus, you basically have, I think, was it 20 or 10 millimole? For H3O plus, 20 milliliters of 10 millimole. Okay. 20 milliliters. Again, 20 milliliters. Change it to liters times 10 millimoles. Change it to moles. أكيد millimole per liter. Change it to mole per liter. You get a value of 2 times 10 to the power negative 4 moles. أنا بشتغل هون بالمول. نفس الشيء. HO minus is 30 times 20, 60. 6 times 10 to the power negative 4. CH3COH was 40, 20, so that's 8 times 10 to the power negative 4. The first reaction will be in yellow. It will be between this one and this one. 2 with 6, limiting is H3O plus. This will be approximately 0, and this will yield 4 times 10 to the power negative 4. Now, you have HO minus and CH3COOH. هيدول التو will now react. Limiting is HO minus. It will disappear, leaving epsilon, and yielding CH3COO minus in a value of 4 times 10 to the power negative 4 moles, not millimoles, sorry. Okay, so in your question أكيد هون بيبقى 4. In your question now you have the acid and the conjugate in same number of moles, يعني same concentration, يعني the pH is equal to pKa, which is what, 4.75. This is the shorter version where you imagine the reactions in your head, and that's it. You can do the reactions consecutively, or you can do this. Number 38. So 37 is done. Number 38. Calculate the pH of a mixture of nitrous acid, which is basically a weak acid, and monochloroacetic acid, again, weak acid. You have two weak acids. The important thing is to look at the Kas. تذكروا, if you have two weak acids, if Ka of one of them is greater than 100 Ka of the second, or in terms of pKa, if delta pKa is greater than 2, you can simply say that neglect the weaker acid and focus on the stronger acid. However, if delta pKa is less than 2, أو ال Ka1 is not greater than is less than 100 Ka2, you have to follow the rule يلي تعلمناها بكل بساطة. When you cannot neglect one of the acids, find ال H3O plus coming from both acids. هون it's not a simple summation, you get it from Ka of the first one times C1 into نقوا مين الفirst ومين السecond. Let's say this is the first and this is the second. Okay, Ka1 times C1 plus Ka2 times C2. Remember this rule, the radical to the power half. You find this H3O plus and then you find the pH, which is negative log H3O plus. Very simple. This is what you do if the rule Ka1 greater than 100 Ka2 is not satisfied. يعني delta pKa is less than 2 instead of greater than 2. Number 39. Consider two solutions, S1 and S2. S1 contains NH3, S2 contains its conjugate acid NH4+. They have the same concentration, which is 0.1. Calculate the volume V1 and V2 that we need from S1 and S2 in order to prepare 1 liter of solution having a pH of 9.6. هلا لو كانت ال pH equal لل pKa كان دغري قلت إنه they need to have the same volume since pH equals pKa and they will have the same concentration. But since pH is not equal to pKa, we have to find the volume of each. And it's very easy to do so. What we do is the following. Number 39. I have the couples NH3 NH4 plus اثنيناتهم 0.1 molar. Let's call خلينا نقول ال NH3 is 1 and the C1 is 0.1 molar. V1 is unknown and the NH4 plus is basically 2. C2 is 0.1 molar and the V2 is unknown. Okay, we start the pH is equal to the pKa plus log NH3 divided by NH4 plus concentration. It means the concentration of NH3 is C1 V1 divided by V total divided by the concentration of NH4 plus is basically C2 V2 divided by V total. Remember, you can just cancel V total. Okay, you have the pH is 9.6, pK is 9.2, log C1 he 0.1, C2 0.1. كمان cancel it, so basically cancel V total with V total and cancel C1 with C2. You get V1 divided by V2. So V1 is equal 10 to the power 9.6 minus 9.2. 10 to the power 0.4 times the V2. So it's basically 2.512 V2. And from the given, they also tell you that calculate the volumes of V1 and V2 in order to prepare 1 liter. That the total volume is actually 1 liter. So V1 plus V2 is equal to 1 liters. Okay, أنا محل ال V1 فيه حط 2.512 V2 plus V2 equal to 1 liter. It means V2 is basically 1 liter divided by, okay, it's equal to 0.285 liters. it's 285 milliliter, and V1 is basically 285 times 2.5, which is 715 milliliters. Very simple. Okay, this is basically just math. That's 39, now 40. In 40, determine the volume V of sodium hydroxide added to 30 milliliter of phosphoric acid to prepare a buffer solution of pH equals 7.5. pH equals 7.5 يعني انتو closer to the couples of pKa2. Okay, يعني basically the predominant species are HPO4 minus 2 minus and H2PO4 minus. So what you do is you just work the reaction. What do I mean work the reaction? Start with هنكتبها هون. Start with H3PO4, add HO minus to it, and then H2PO4 minus, remember, plus H2O. This has to be completely neutralized لأنه نحن بعدنا عن the predominance region of these two couples. So initially you have 30 times 0.1, you have 3 millimole. The value of HO minus is not known. It's basically 0.5 times the first volume for the first reaction. At the end, you get a value of epsilon. Okay, let's say it's like epsilon 2, okay, even though you cannot say that لأنه أكيد you have a remaining, and 3 millimole. The remaining value يلي هون will react in the second reaction. Why will react in the second reaction? And from the value of pH, I know that you move to the second reaction, the predominance domain. In the second, you have H2PO4 minus plus HO minus, HPO4 2 minus plus H2O. In this, you are stuck in this reaction. You do not go forward to the third one. Why? Because this is the one, this is the second couple, is the couple that dominates pKa2. pH is closer to pKa2, so the second couple is the couple that dominates in the reaction. بنكفي عادي. Initially I had 3 millimole of H2PO4 minus, 0.5 V2 of the second reaction. At the end, and I'm stuck in the second, so I cannot say that HO minus is the limiting. If you are stuck in the second, it means HO minus has been consumed. It means HO minus is now a value of epsilon. This is 3 minus 0.5 V2, and this is 0.5 V2. The idea is to find V1 and V2. نيجي لهون. Let's find the volume V1 from 1. To find V1, قسمت الفاليو أنا of HO minus هون ل 2. One that reacted in reaction 1, one which remained from it reacted in reaction 2. So all I have to do is find how much reacted in 1 and how much reacted in 2. And then I do the total. So find V1 from 1. Bil V1, basically, I have 3 millimoles minus the value of HO minus, اللي هي 0.5 V1. This is not the complete value of HO minus, and this changed into a 0, which is why it's not the complete value of HO minus. V1 needed to neutralize H3PO4 is basically 6 milliliters. Okay, very simple. But this is not the total volume or value of HO minus, because a second value was used for the second reaction. From the second reaction, 3 minus 0.52 equals to what? This is what we find from the pH. Okay, so basically we have to go pH is equal to pKa plus log 0.5 V2 divided by 3 minus 0.5 V2 divided by the volume total. هيدي it's okay. Okay, the pH is 7.5, pKa 7.2. Find V2. V2 is equal to around, you get around 3.99 ml, so that's 4 ml. To completely neutralize the first reaction, I knew that I have to neutralize the first reaction because according to my pH, I'm stuck in the second couple. This is how I knew I needed to completely neutralize the first reaction. Okay, so from the first reaction, the value of HO minus has to completely disappear. In reality, it doesn't لأنه remaining. However, أنا ما بستخدم هون the total volume. قسمت الvolume into two volumes. The volume that worked in the first reaction and the volume that worked in the second reaction. So you find the volume that worked in the first reaction by simply saying إنه 3 millimole بدها بالنهاية تصير زيرو لأنه H3PO4 is completely neutralized لأنه أنا طلعت من predominance domain اللي إله. So 3 millimole minus 0.5 V1, they have to be equal to 0. So you basically find V1, which is 6 milliliters. Good. You go into your second half, which is the second reaction. From the pH, you know that you are in the predominance domain of the second reaction. So the second reaction is not completely consumed. You need to have a remaining value of H2PO4 minus. And you call the second volume of HO minus V2. So it's basically 3 millimole minus 0.5 V2. But in this case, this value is not zero لأنه you are stuck in the second reaction. You don't know what value remained. لو عندي ال H2PO4 minus remaining, it would be good, but I don't have it. How can I find it? From Henderson-Hasselbalch. So you go to Henderson-Hasselbalch, you put the pH اللي هي 7.5 is equal to pKa plus log 0.5 V2 على 3 minus 0.5 V2. You find V2. The total volume of HO minus needed for this reaction was the volume used for the complete neutralization of H3PO4 and the volume needed to partially neutralize H2PO4 ليصير عندنا pH 7.5, which is V2, and this is 10 milliliters, 6 plus 4. Okay, good. And this is number 40. We will save number 41 or 42 for next time.